Hello, Year 10s. So, this week we're going to focus on combustion, and hopefully, this is bringing together some things that you've already come across in Key Stage 3 and during your GCSE course. So, hopefully, this will just all bring it together. Now, to begin with, I'm going to put some questions on the screen. What I would like you to do is I'd like you to pause, see if you can answer. You don't need to write them down. You just need to answer them out loud. And then as we go through the lesson, hopefully you'll be able to master the answers to those questions. Okay. Hopefully you've given yourself enough time to have a look at these questions, see how much you already know. And then what I'm going to do is I'm going to take you through this section. You can just sit back and watch. And at the end, I'm more than happy if you just print the notes to put into your book. Okay? So let's make sure you understand. Okay, so to start off with, okay, so focusing on combustion, we know that there are two types of combustion. There is complete combustion and incomplete combustion. Now we're going to start off with complete combustion. And for that, we need a fuel, we need oxygen, and in that reaction, well, first of all, we know the fuel won't burn unless oxygen is present. So the fuel plus oxygen is going to always produce, it doesn't matter what the fuel is, it is always going to produce carbon dioxide and water. So that's your general equation. And it is an exothermic reaction. So lots of heat energy is going to be given out during the reaction. Now, if we had to give an example, so let's just say we were burning methane, CH4. So we would then, the symbol formula for oxygen being diatomic would be O2. We would get CO2 plus H2O. Okay, so nice and easy. Just remember that general equation. Fuel plus oxygen gives you carbon dioxide, water. And then whatever they put in as the fuel, you'll be able to work out the answer. Okay. So how did they work out that these were in fact the products of combustion? Well, there's this very simple experiment, and we could do it in the lab where we take a Bunsen burner, an inverted funnel. So we collect the gases that are burning as the gas is burning. And we have this U-shaped tube, and we put it in a beaker of ice so that when the gas hits the surface, the gas condenses and forms a liquid. And inside there, we put some cobalt chloride paper. And if it turns pink, we know that that is in fact water. And in the next tube, we put some lime water. So as the gas bubbles, if it turns cloudy, we know that the gas formed is indeed carbon dioxide. So looking at the test, carbon dioxide, we know very well by now. We use lime water and it goes from colorless to cloudy. For water, I can use blue cobalt chloride paper, and if water is present, only then will it turn a very pretty light pink color. Another test for water that's worth knowing about is I can use white anhydrous copper sulfate. It's a white powder. And if water is present, that powder turns a very pretty blue color. Okay, so that's what you need to know about complete combustion. Now let's divide the page for the next bit, which is incomplete combustion. Now the key thing to remember with incomplete combustion is you are missing a key ingredient. You have little or no oxygen present. And because of that, in the word incomplete, we've added two more letters, the in. It reminds me that we get two more products in our reaction. Okay, so let's have a look at the reactions. I start off with my fuel. This time there's little or no oxygen. So that's got to be your light bulb moment that we are now into incomplete combustion. and that produces carbon dioxide and water. So far it's exactly the same as complete combustion. But here's the two things you need to add in. You also get carbon monoxide, mono meaning one, as opposed to dioxide meaning two, and carbon on its own. Now, we need to understand what are the issues related with incomplete combustion. And very often, they'll ask this question in exams, and very often, GCSE students lose marks because they say they cause pollution. Folks, for GCSE to do well, they are looking for scientific details. So pollution is not a good enough answer. So let's have a look at the possible answers we could put down. So for carbon, carbon is basically soot. And we know that it makes walls black, it makes pipes black, it lines the inside of your chimneys. And the problem with this soot is it collects in your lungs, and it could cause things like asthma. And that, of course, leads to breathing issues. Carbon monoxide, the problem with carbon monoxide, it is toxic, it's colorless, and it's odorless. So people don't realize it's forming until it's too late. And that's why if you've got a fuel in your house, for example, you use oil or gas central heating, it's vital you have a carbon monoxide detector. So why is carbon monoxide such an issue? Carbon monoxide will join onto your hemoglobin of your red blood cells that carry the oxygen around your body far more easier than oxygen does. And that means that your body carries around the carbon monoxide and not the oxygen. So you suffocate and could die. So very, very serious. And then carbon dioxide. Well, we know that carbon dioxide leads to the greenhouse effect. It leads to global warming, and that brings about a number of different issues. So, for example, we know that the icebergs melt. We know that as a result of that, the sea levels start to rise. That causes flooding of land. And that in turn causes a loss of habitat for animals, for people, and for animals in particular and plants, the species starts to decline. There is less land for crops, for both less land for crops and indeed for people. And we know now that we are getting people that are having to move homes as a result of this. The other issue with carbon dioxide is a soluble non-metal oxide. Now we know that the metal oxides form alkalis. Non-metal oxides, they tend to form acids. So what happens is this acid forms in the rainwater, and if it's carbon dioxide, you end up with carbonic acid, H2CO3. Now, we know that very often fuels have natural occurring additives, impurities inside them, rather than additives, they're impurities like sulfur. And we know that if sulfur in the fuel reacts with oxygen, again, an oxidation reaction because oxygen's being added, it forms sulfur dioxide, another soluble non-metal oxide. And this time, when sulfur dioxide reacts with rainwater, it produces sulfurous acid, H2SO3, and that continues to react with oxygen, and it forms sulfuric acid, H2SO4. And that, of course, is acid rain. And yes, it is a real thing. The problem with acid rain is the soil gets acidic, crops don't grow, lakes get acidic, which means that fish eggs don't hatch, and it affects the fish and the insects in that habitat. And it also causes weathering. So, for example, if you have structures made out of limestone and marble, which is calcium carbonate, the acid reacts with the carbonate, and we know from our chemistry, acid and a carbonate gives you salt, carbon dioxide, and water. So those buildings and statues and those rocks, like the Cliff of Dover, start to break down. Okay, now the next one, let's just move me out the way. The one last thing I want to add for this little section is what happens with the engine of your car. So in the engine of your car, as your fuel's reacting with oxygen, there's a huge amount of heat. And we also know that in the air, we know air is made up of 21% oxygen only, 78% nitrogen and other gases. Now that nitrogen and oxygen in your internal combustion engine gets so hot, it actually causes the nitrogen and the oxygen in the air to react. And the problem with that is nitrogen plus oxygen produces nitrous oxides. Now, these are the gases, nitrous oxides are the gases that are removed by your catalytic converter in your car. But if it's not removed, and if some are released into the atmosphere, the nitrogen dioxide, NO2, which is a toxic reddish-brown gas, that causes things like bronchitis. It irritates your lungs again. But that nitrogen oxide, when it reacts with water, what is it going to do? Just like with some of the others, it's going to form acid rain. So that nitrogen oxide going up into the air reacts with water from the clouds and it adds to the acid rain. And the thing with acid rain is I could be producing it in a place like Germany, the clouds move over and it can drop it in a place like Belgium. So all of these are very real issues. Right, now go back to your questions that you started off with and see if you can answer them better. This is the picture you need to have in your head when you answer questions related to complete and incomplete combustion. And there we have it. Well done. I wish you the most wonderful summer holiday. Recharge your batteries. Make sure this is all filed in your book, all put away nice and neatly so you can start off from here in September. You should be so proud of yourselves. Excellent work. Well done.